focus.
I had a nightmare.
Everyone does.
Wow, hello!
I see you.
I see you.
I see you.
I see you.
I wondered if Abraham really had made a hash of life.
I've been searching through rains and the wind that follows after for one certain fate.
Loca, loca, chica loca, 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 muy golosa, loca, loca, vanitosa, loca, loca, vanitosa.
LTX 2.3 is the latest version of the LTX series of audio-video generation models. Like its predecessor LTX-2, it can directly output 1080p HD video with audio on consumer-grade graphics cards in just a few minutes. Moreover, prompt understanding and audio quality have both seen noticeable improvements. However, there are also some frustrating drawbacks, such as end-frame collapse and visual subtitle hallucinations, which cannot be completely resolved. We can only use various methods to try to avoid them. In today's video, I will walk you through a detailed breakdown of LTX 2.3's core usage, looking at how good the videos it generates can be, what bizarre problems you might encounter, and how to solve them. After watching, you can make your own judgment. Is this large model worth downloading to your hard drive? Let us first look at the model files you need to download. Like LTX2, the officially released large models are checkpoint files in BF16 at 46.1 GB, FP8 at 29.1 GB, and NVFP4 at 21.7 GB formats. There are both full versions called DEV and distilled accelerated versions, all containing the main model, text encoder, and VAE. However, you also need to add Gemma 3 as the text encoder, though if you have used LTX2 before, you should have already downloaded it. Generally speaking, those with 16 GB or more VRAM can directly download these two FP8 version checkpoints. For 50 series graphics cards, you can choose the NVFP4 format, which is smaller, faster, and the quality is not compromised. KJ has shared the separately extracted main model, text encoder, and VAE for more flexible use. Unsloth has created GGUF versions of the model. If you are tight on VRAM, such as only having 12 GB VRAM, you can absolutely use Q6K and still get good results, but this means you need to download the text encoder and VAE separately. Like LTX2, the official release also provides a distilled LoRa and upscaling models. For our workflow, we need the spatial upscaling model, and version 1.1 performs far better than version 1.0. Open Comfy UI and first check the version. My local version is 0.17.1 with template library at 0.9.21. Comfy UI announced support for LTX 2.3 in version 0.16.0, but subsequent versions continued to fix many LTX-related memory and VAE issues, so I recommend using a newer version for the experience. Open the template library and you can see that the Comfy UI official release provides 3 LTX 2.3 workflow templates: text-to-video, image-to-video, and video generation with both image and audio input. The LTX model official team also provides several workflows, including single-pass sampling and 2-stage upscaled text-to-video and image-to-video, video transfer supporting ControlNet signals, and motion tracking image-to-video. However, I personally don't really like their implementation style. For example, they heavily use subgraph encapsulation to beautify the interface, making the logic opaque. They also rely on local resources for enhanced prompt. The most awkward part is that their text-to-video workflow actually includes an image upload node, but it is never used during actual sampling. So in this video, I will demonstrate using my modified workflows. LTX 2.3 and 2.0 models share the same lineage, so let me first load the LTX2 text-to-video workflow I shared previously. Modify each model loading node. As we mentioned in the model introduction section, only the Gemma 3 in the text encoder can be reused, while all other models need to be switched to their 2.3 counterparts. The first stage uses the full dev model for better results. The second stage sampling loads the distilled LoRa and uses the upscaling model for upscaling. Note that the upscaling model should use the latest 1.1 version, which is much better than the earlier 1.0. Let me change the prompt to the Camera Girl demo from LTX2 to compare the new model and see if there is an upgrade. LTX 2.3's prompt principles are basically the same as LTX2, both requiring single paragraph format containing camera language, action sequences, scene descriptions, character details, lighting and texture, audio and dialogue elements. The new version just supports longer prompts with more accurate audio details. Long lines can be broken into short sentences with performance cues. Reusing the previous prompt generation instructions and nodes from Maya nodes works fine. Set the size to 11920 by Troupe 88. As we introduced with LTX2, this series of models' biggest advantage is the ability to directly output 1080p video on consumer-grade graphics cards. Because it is a large-size video, I am using a local 16GB VRAM 588A, so it is best to change the temporal size in the VAE decode tiled node from 4996 to 64, which can effectively reduce the possibility of OM. Finally, modify the phylum in the video save node. Click Run. Here is the result.
The lighting here is absolutely perfect today.
Excellent lighting effects, natural backlight halo on hair, smooth character movements, and very realistic coat fluttering. However, there are some minor issues. After the character turns around, the camera holding gesture is slightly off. Comparing with the LTX2's same workflow result,
The lighting here is absolutely perfect today.
2.3 has richer details and crisper audio quality, but it cannot be called a complete upgrade. For example, I actually prefer the final smile in the LTX2 version. In this workflow, we use the Res L2S sampling recommended by LTX2, but in the new version, the official team recommends using Euler Ancestral CPP and Euler FCPP as the sampling methods for first stage generation and second stage upscaling respectively. Let me switch them, keeping other parameters unchanged, and generate again.
The lighting here is absolutely perfect today.
This result has a clearer subject and higher saturation, but slightly weaker lighting atmosphere. The camera model change should be due to seed influence. I also ran comparisons of different sampling methods with other prompts. Overall, I prefer the results from this sampling method combination, gentler tones, and the characters don't look too greasy. LTX 2.3 also supports direct input of Chinese prompts. Let me switch to Chinese prompts in this workflow and run it. Similar to LTX2's performance, the resulting video has Asian-looking characters, but there are three obvious drawbacks. The last frame is blurry, the character speaks with an accent, and there are incorrect subtitles. If we switch to English prompts and only change the dialogue content to Chinese, the result would be like this.
今天这里的光线太完美了。
The Chinese sounds much better, but the last frame and subtitles still have issues. These are what I consider the two major flaws of LTX 2.3 after using it for so long. First is end frame collapse. The last few frames of the video often show high saturation color blocks, noise, or hallucinated text. One theory is that this stems from tail-end contamination in training data. When the video is about to end, the model tries to force generate an ending credit, causing the video to become distorted. We will demonstrate later how to use nodes for physical removal, keeping only the normal segments. Second is visual subtitle hallucination. When non-English dialogue is involved, the model tries to paint subtitles, but due to lack of cross-language typesetting ability, it ends up generating a string of seemingly meaningful, but actually nonsensical, garbled text. Currently, you can only write extensive subtitle-related prompts in the negative prompt to suppress this, but it actually only slightly reduces the probability. You still need to re-roll multiple times. If you have a 50 series graphics card, I recommend using the NVFP4 model even more. It is faster and produces better results. Here I am showing the results running on a
The lighting
5080.
here is absolutely
However,
perfect
pay
today.
attention to the running time. If it is slower than
The
FP8,
lighting here
your
is
graphics driver
absolutely
is
perfect
probably
today.
not new enough. If you want to use a GGUF model more suitable for your VRAM situation, switch the model loading node to a GGUF model loader. Note that it only contains the main model and needs to be paired with separate text encoder and VAE. In this workflow, with the same prompt and parameters,
The lighting
the
here is
Q6 version
absolutely
produces
perfect today.
acceptable results. LTX 2.3's FPS is similar to LTX2, supporting various choices such as cinematic 24 FPS, general purpose 25 FPS, and 30 FPS better suited for fast action. The official team thinks 48 and 50 are also quite good. I have even run 60 FPS without issues. Higher values mean more total frames for the same video length. The frame count should still follow the rule of multiples of 8 plus 1. For size, I suggest these options. Landscape from small to large is 1280 by 704, 1920 by 1088, 2560 by 440 mig 1040. The higher the resolution, the more VRAM required. However, a major advantage of LTX 2.3 is native vertical video support. It is trained on native vertical aspect ratio data, not content cropped from horizontal videos, so the composition and detail performance are more natural. Here are some official examples. Let us change the size to 1088 by 1920, paired with this set of highly dimensional 3D animation prompts for generation.
Wanna dance?
The resulting composition has excellent balance. The character's proportion in the
dance?
frame is very harmonious. In the final push-in shot, the perspective synchronization between foreground grass and distant sea horizon
dance?
is incredibly realistic. I am very satisfied. All the demonstrations so far have used the full dev model for first-stage sampling, then paired with distilled low-WAR for upscaling. While quality is stable, speed is considerably slower. However, LTX 2.3's distilled model is much stronger than the previous generation, and using distilled models for the entire workflow also produces good results. Let us try it. Using the same camera girl prompt as before, this time we directly move the distilled low-WAR loading node to the first stage. Note that CZG should be changed to 1, and sampling steps should match the official recommendation using a defined set of sigma values. Click Run. Generating a 1080p video this way only took 4 minutes, saving nearly half the time compared to the previous workflow. This efficiency is truly impressive. Let us look at the result.
The lighting here is absolutely perfect today.
The most intuitive feeling about the image
The
is that
lighting
the
here
motion
is
logic
absolutely
remains
perfect
stable.
today.
From the girl raising her camera to turning her head and speaking, the action
The lighting
transitions
here
are
is
very
absolutely
coherent.
perfect today.
Especially under strong side backlighting, the red brick wall texture and clothing
lighting
folds
here
are
is
well preserved.
absolutely perfect
Of
today.
course, careful comparison reveals that the distilled version is indeed slightly flatter than the
The
full
lighting
model
here
in
is
terms of facial
absolutely perfect
microexpressions and lighting subtlety. But considering this speed improvement, the image quality performance is completely within acceptable range. However, when using the distilled model, CZG is 1, which means negative prompts will not take effect. If we want to exclude annoying subtitles or noise, what should we do? Here we can use the LTX2 neg node from KJ nodes. It works by injecting a layer of neg-A, or normalized attention guidance form of negative guidance, at the cross-attention layer, achieving an effect similar to native negative prompts. Add this neg node, keeping default parameters. I usually add a reroute node after the low-WAR loading node, which makes it easy to connect a new node into the existing workflow. Remember to connect the negative prompt to both the video and audio negative conditions of the neg-A. Click Run. In the same 4 minutes, we get this video.
The lighting here is absolutely perfect today.
The running time has no obvious difference, but the effect is very intuitive. The red brick
The lighting
wall
here is
gap
absolutely
textures,
perfect
the
today.
girl's facial details, and hair sharpness are all significantly improved. The visual impression is now very close to the full model level. If you prefer using the dual distilled fast workflow, I strongly recommend including the nag node to improve image quality. If you encounter this error during use, you need to upgrade KJ nodes to a newer version. LTX 2.3 supports using LoRa models trained on LTX2 without any loss in effectiveness. To verify this, let us remove the AG node and restore the workflow using the full model to generate the camera girl. Before first stage sampling, I load a classic Ghibli-style LoRa with weight kept at 1. At the same time, add its trigger word at the very beginning of the positive prompt. Click Run.
The lighting here is absolutely perfect today.
The resulting video style has undergone a complete transformation. This typical cel-shaded flat coloring, fresh contrasting tones, and highly distinctive character lines are the classic Ghibli style. However, just as the video is about to end, large areas of mosaic blocks and severe color tone breaks suddenly appear. This is the end frame collapse we have repeatedly mentioned. Since the model cannot handle it well itself, we will manually cut it out. Here we use the Select Images node provided by the Video Helper Suite plugin. This node supports multiple selection logics. Here I directly enter 0 and 1, which means getting all images except the last one, which is the frame 1, then recombining them.
The lighting here is absolutely perfect today.
You can see that after physically trimming the last frame, the new video performs perfectly. By the way, the VAE decode node in the LTX video plugin actually has a fix last frame option. Its principle is to first add a frame and then crop it during output. But in my actual testing, the effect is unstable. In comparison, directly performing surgery on the bad parts is still the most reliable. That covers text to video. While using large language models to re-roll can indeed produce many surprises, in my opinion, image to video is the real productivity tool. The reason is simple. We can first use professional image models like Z-Image Turbo or Flux2 Klein to precisely customize a high-quality, aesthetically pleasing base image. With a clear initial frame, the randomness of video generation is greatly compressed. Prompts can then focus more on controlling motion effects and camera movement, reducing descriptive content. For example, right now I want this group of kittens to do a group dance. If using text to video directly, even with hundreds of words of complex prompts, the model would struggle to precisely generate these specific cute pajama-wearing kittens out of thin air. But in an image to video workflow, you just need to upload the image, write a prompt mainly focused on the kitten's dancing movements, and click Run. The video size is 1280 by 704, which is a standard 720p landscape video. Even with this complete workflow using full model and distilled model for two-stage sampling, it only took 2 minutes to generate. Look at the result. The kitten's sense of rhythm and consistency are maintained quite well. However, during the final turn, this blue cat's head twisted in the wrong direction, which is a bit scary. We can remove this ending segment or re-roll a few more times. I also ran these 2 other videos, and they perform perfectly. Image to video also supports direct audio upload, which unlocks more possibilities. Let me switch to this workflow. Compared to regular image to video, 2 main adjustments were made. First is the new audio input section. The uploaded audio is passed to the model after being encoded by the audio VAE. If you only want the model to reference human voice, such as making singing videos, you can use these 2 nodes to extract the vocals track. Second, use the audio length to dynamically define the video frame count. The formula is audio duration multiplied by frame rate, aligned to 8 frames, plus 1 trailing frame buffer. If you feel the ending is too abrupt, you can add a few more frames. Since the original audio has already been input, you should use it to replace the audio generated by LTX-2.3, and the prompt can remove all descriptions about sound. Watch the result. The most intuitive feeling is the sense of rhythm. The kitten's twisting frequency indeed follows the music beat. However, compared to the nodding dance workflow I made before, LTX 2.3 model seems to only have rhythm, without referencing the audio's amplitude characteristics. Simply put, the beats are accurate, but the sensitivity to volume ups and downs is not as pronounced. The earlier prompt was dance. If you add sing, the model will try to make the character lip sync with the lyrics. So, using LTX 2.3 to generate digital human talking head videos is also a good choice. Upload a male portrait as the first frame. Adjust the size to 720p vertical, which is more suitable for short video platforms. For audio, I selected a segment from The Moon and Sixpence, totaling 20 seconds. As mentioned earlier, when you only need the vocal track from the audio, you can enable these two nodes for extraction, which can maximize the elimination of background sound interference with the model. The prompt can be kept super simple. Generating this 20-second video took a total of 8 minutes.
I wondered if Abraham really had made a hash of life.
Compared to dedicated lip-sync tools like Infinite Talk, LTX 2.3's advantage is richer body movements and more natural overall dynamics. Of course, the disadvantage is also obvious. Its lip-sync accuracy is relatively weaker, and limited by VRAM pressure and running speed. It is not yet suitable for processing minute-level super long content. LTX 2.3 provides an IC LoRa that supports input of canny edge, depth, or pose control signals for video transfer. I will directly load a workflow heavily modified based on the official template. The model selection section is no different. FP8, GGUF, or original models all work. Let me demonstrate with a group street dance video from Buki Dance Troupe, changing the first frame base image to a group of kittens in the same poses. Note that the width and height set here are not the final video size. This is mainly to prevent your oversized input from crashing the workflow. Upload the video, skip the slower first 200 frames, and directly load the middle 121 frames to generate a 5-second video. Focus on the control section. These three groups of nodes correspond to depth, canny, and pose preprocessing respectively. Depth and canny are usually used for style transfer, while pose has higher freedom. For this demonstration, I will use the pose reference video generated by DDAO-Pose. Here is a math node ensuring the input reference video's width and height are both multiples of 32 as required by the LoRa. Without this alignment, the workflow will error out. The sampling section is still the two-stage configuration with full and distilled models. In the first stage, load the IC LoRa, which reads the control video and updates it into the positive and negative prompt instructions. We can flexibly adjust the first frame image and control signal strengths through these two parameters. Note this LTX-V's crop guides node. If you modify the workflow and find the generated video is corrupted, most likely you forgot to connect this. Click Run. And in 4.5 minutes, you get this video. The effect is no worse than scale. Even facing such complex street dance movements, this group of anthropomorphic kittens learns it quite well. The limb alternation and center of gravity changes are very realistic, with extremely high motion consistency. LTX Official also provides a motion trajectory control workflow. Although I haven't found particularly practical scenarios yet, since the effect is quite obvious, I will demonstrate it for everyone. Load each model. The trajectory tracking LoRa also uses the IC LoRa loader. We input this seaside anime girl base image and describe in the prompt the scene of her facing the sea and smiling in the wind. The core is this trajectory settings node. The original workflow has two preset paths. During use, you can left-click to adjust nodes, right-click to add or remove paths. I will keep the defaults for now without adjusting. This workflow is relatively lightweight, using the distilled model directly for single-pass sampling. Click Run. It finishes in less than 2 minutes.
Would you like to dance?
Watch the result. These two preset trajectories are indeed a bit strange.
Would you like to dance?
The young lady is walking and about to walk right out of the frame. However, if we switch to this set of trajectories, the character's performance becomes much more natural. You can see that trajectory control over frame displacement is relatively strong. Interested viewers can experiment with it. More operations won't be demonstrated. Let me summarize. LTX 2.3 perfectly inherits the core advantages of the previous generation model. It can still directly output 1080p HD video on consumer-grade graphics cards, supporting synchronized audio-video output and multi-language prompts. At the same time, it can directly reuse the LTX2 LoRa ecosystem. There are improvements in prompt understanding, audio quality, and native vertical video performance. Beyond regular text-to-video, image-to-video, and audio input features, we can also use the official IC LoRa and Motion Track LoRa for precise video transfer and motion trajectory control. offering very diverse possibilities. Of course, it is not perfect. When handling complex movements, the logic still tends to make errors. There are also two obvious common problems: end frame collapse and visual subtitle hallucinations, which require workarounds. Overall, the LTX 2.3 model is definitely worth using. Alright, that's it for today's video. If you found this content helpful, please give it a like to support. All models and resource links mentioned in the video are in the description. Feel free to grab what you need. See you in the next video.